Installment for this academic year of the ODU Invited Seminar Series. There's a sign-in sheet going around the room. Oh, I forgot to make the slide. Rats. There's a sign-in sheet going around the room. If it missed you already, I'll make sure it comes back down to the front for people who came in on time.
I was 5
You were on time, that's why I said
I was 5 minutes early.
So by popular demand, we've had lots of people saying, hey, we want something to do with medicine, but I didn't want to bring in just a medical doctor, that's boring, so I brought in a medical technology, what do you want to call your job? Technology transfer specialist. Yes, so this is like kind of the more businessy side of medicine. But she comes from a background of more of a traditional biology, PhD, study, research kind of thing to segue her career in this direction. Come on in, you're fine. But I was specifically instructed not to give a lot of background because the background of her entire career is kind of the point of the talk. So if you're a biology major and you're like, man, I'm not 100% sure what I want to do with my career, remember that there are options that are not doctor or PA or nurse. Great. So let's welcome Dr. Catherine Murari-Kanti, who may or may not be related to some people in the audience.
Thanks guys for having me today. I'm really excited to be here. I've done a lot of talks with undergrads before, not in Ohio, mostly. I'm from Nebraska, so I've done a lot of talks over there with undergrads in high school, just career-based talks. So this is a little different. I'm going to talk about what I'm doing right now, and then I'll segue halfway into my story of how I ended up being here and doing what I'm doing as a PhD scientist. So I do not want this to be a one-way conversation. Shoot questions at me, say what you want. It's be chill. I don't want this to be super serious. I'm not a serious person, and so let's have fun. Let's talk. Ask questions, even if they're dumb, even if they're stupid, and if they're unrelated, just shoot them. So happy to be here. I am from Atlanta. Obviously, you can see my title. I work at Emory University. I flew in on Saturday. I am Matthew and Grace's aunt in the audience, and then I fly back in about 3 hours back to Atlanta tonight. So thank you for having me. Before I say anything, I have to have a disclosure statement, as I was instructed by Emory, that I have no financial interest in anything that I'm doing over here. Dr. Little's not paying me to talk today, so there's nothing of that sort. And whatever I say today are my own thoughts. They're not reflective of anything I say about Nebraska or Emory University. All right, so before we go, I just wanted to get an idea of the room, what you guys know about tech transfer. So let's do this, guys. Have you come across the term technology transfer before this presentation or its announcement? Don't tell me you saw the announcement so you know what tech transfer is. Before that, did you know what tech transfer is? I guess everyone's done? Wow. That's good. I assume people would know, but 5%? Oh! Is everyone done? Okay, well, I'm surprised, but not too surprised because this is usually the response I get. All right, let's go to the next one. Do you have an idea that you think can change the world? No ideas are dumb, in my opinion. No? No? Come on, guys. Okay, that's good. All right, so then to my last question, do you know how to protect or commercialize that idea that you have in your brain? Okay, so the majority don't really know the steps or the methods of how to do this. So that's where I step in, and I'm going to talk about that a little bit. on how the commercializations of ideas happen. So let's just talk about some examples. We all drink Gatorade. That's a common drink. And you're sick, you're throwing up, or you're in a football game, whatever. You get a Gatorade, it's normal, but it actually is a patented idea from the University of Florida. It was named Gator because of the Gators, and so it's Gatorade. So in 1965, a team of scientists were finding football players passing out or throwing up after a game because they just lost all the electrolytes. And so a bunch of researchers from the University of Florida came together and created this patented method of creating Gatorade, and then they patented it, and now they have royalties in the billions from this drink. Another example is the Honeycrisp apple. I don't know if you've tried it at the grocery store. It's kind of sweet and tarty at the same time. It's actually a patented genetic sequence that was created by the University of Minnesota, and they bring in about $6 million to the University of Minnesota every year just from an apple, just an idea. Let's talk about your memory foam mattress. Guess where that came from? NASA. NASA has a patented technology that they created to help these astronauts when they take off and they get sunk into their seats to protect their vertebrae and to protect their sacral area. They created this specific memory foam mattress in their seats to help them during takeoff. And now, of course, we sleep on them as well. So it's a patented technology. I think NASA then gave it away because it was for the good of mankind, and so they don't really make a lot of money on it, but it's a patented technology. Think about Google. 2 kids at Stanford University decided to create a software technology in their dorm room, and then when they first presented it to an investor, the investor said it's a stupid idea, and then they kind of were disappointed, came back, worked on it, and then showed it to this other investor, I forget the guy's name. He gave them $100,000 as an investment to grow it, and then it gave birth to Google. It was named after the name Google, Googol, which is a number 1 with 100 zeros after it. That's the name where Google came, but that's a patented technology, and now, well, I don't need to tell you about Google. So there is a lot of benefit to ideas. There's a lot of benefit that comes from the commercialization of these ideas. So just a brief thought about how these ideas affect the economy as well as society. So on your left, you have a short summary of how it affects your economy. And this is a study from 1996 to 2017. The concept of commercializing ideas has added about $1.9 trillion to the U.S. gross industrial output. There were about 500,000 inventions that were disclosed. Out of that, there were about 200,000 patents issued. I'm going about the number, but these are numbers that affect our economy. And you and I sitting here, you may think, what have I got to give here? But you have ideas in your brain. And these ideas can then be pushed into society to create benefit to the economy. Well, on the right, you have how this affects the society economy. Let's start at the research and development part of the circle. You get this money that comes into the university to do research. That money then goes into developing of inventions that come from the university. We evaluate it, we protect it, we market it, we license it to big pharma or other companies, and new products are formed. These products are affecting society in a positive manner. And then you also have startups and other companies that get formed, again affecting society and economy. So just a little bit of history about this. Pre-World War II, there was no funding for universities. None of the university professors got money to do research. All of the money was in the government. All of the money went into either agriculture or weapon development. That's all that happened. After post-World War II, I think it was President Roosevelt, he created the OSRD, which was specific money that was put towards specific scientific projects. And then after that, I think in the 1980s, Senator Bay and Senator Dole were responsible to create this piece of legislature where they said that if the government is giving the university money, then the university should be able to patent that idea and also commercialize that idea. That is where the concept of technology transfer came to birth. So before this, all of the ideas that were generated, all of the science that was done was all protected by the government. The government would patent it and store it in its vault, so to speak. And nothing good would come out of those ideas. But after this legislation passed by Senator Bay and Dole, it's called the Bayh-Dole Act, universities were able to take these ideas, protect them, and commercialize them. And that's how the whole concept of technology transfer came into place. So I'm just gonna play a little video over here to show you what technology transfer is, and then I'll talk about it. Oh, I don't have volume, guys. Anybody help?
Using your own computers.
Current labs conduct research, generating groundbreaking discoveries. These breakthroughs can improve the way we live, work, and play. Technology transfer professionals play a central role in connecting these discoveries with companies that can turn them into products to make the world a better place. Government and private organizations provide the critical funding that supports this research to help find the next new discovery. The process called technology transfer works to protect and advance these discoveries through copyrights and patents, and by creating partnerships and startups to turn research ideas into new products and stimulate the economy. Sounds simple, but there are many steps involved in turning an idea into a product. Lots of challenges. Some ideas make it, some don't. Sometimes an idea is transferred to an existing company, and sometimes discoveries inspire the creation of a brand new company. These companies turn new ideas into products that can have a huge impact on improving lives, creating jobs, and supporting the next generation of research discoveries. To learn more on the many ways that technology transfer is transforming ideas into opportunities around the world.
All right, so that's just
Every day.
So that's just a very small video explaining what technology transfer is. And so I just wanted to take that as a background and tell you what I do as a senior licensing associate at Emory University's Office of Technology Transfer. So for example, I'm going to take you through a story of how an idea goes to a full product and how I get involved in that. So for example, someone like Dr. Little will come to me and say, hey, I have this library of chemical structures that can be the next generation of antibiotics. I'm like, great, cool, that is amazing. Have you tested them? You know, are they truly novel? He's like, I don't know if they're novel, but I've done the testing and they really seem to be working against these strep B, whatever, the bugs. And so, my brain shut down for a minute. So then I'm like, great, okay, why don't you submit what is known as an invention disclosure form? And so there's a form where he fills in and he tells me all this information. What funding he used to study for that? Did he get funding from any other outside sources? What are all the data points that he has chosen? How will this affect society? All of that information he gives to me. And then he also tells me who else contributed to this discovery. Did he work with a graduate student? Did he have an outside person work with him? All of that information. How much each person, whose role it was Dr. Little at 100%, or was he at 50% that he worked and somebody else added another 50%? All of that information will be in an invention disclosure form. That invention disclosure form comes to me in the office. I'm like, oh, this is great, this is amazing, maybe this is the next generation of antibiotics. I call Dr. Little, I'm like, hey, let's get a meeting, let's talk about these next generation antibiotics. He's like, great, all right. So we set up a meeting, we do a Zoom call, he shows me his entire data, he shows me his chemical structures, and I tell him, hey, Dr. Little, are you getting ready to publish this, or have you disclosed this to anyone? He's like, no, I haven't. It's in my lab notebook, nobody knows about it. I'm like, great, keep it that way. We don't want to share it with anyone, not even your grandma. No one needs to know about this is a secret. He's like, okay, great. So I take that information from him, and I have been trained in searching for chemical structures. I'm only giving you an example of a chemical structure. This can apply to a medical device, it can apply to a research tool, it can apply to cancer therapeutics, it can apply to entire rooms of surgery, how that is set up, the protocol, all of that can be patented. And so I talk to him, I take his chemical structures from him, I ask him for the IACUC name, I ask him for all of the strings that he used to name these particular chemical structures. I run them through my software, and I see if there are any other existent chemical structures out there. Now maybe I find a few that match, and I reach out to him and say, hey, Dr. Little, out of the 20 compounds that you shared with me, I find that 5 are not novel, but 15 are novel. He's like, oh, that's great, that's amazing, perfect, okay. So I'm like, what do you want to do? Do you want to publish this? He's like, yeah, in about a month I want to publish this. I'm like, great. So then I talk with Dr. Little, I introduce him to my IP lawyer in the office, who's, for example, Jim. I'd be like, hey Jim, Dr. Little has these compounds, this library of compounds, let's file a patent on it. He's like, great. So then we have a meeting again with Dr. Little. We look through all of those compounds. Jim does his due diligence to make sure they are truly novel. And then he and I work on creating a full patent application. A full patent application can run up to 30 to 120 pages. It has a specific language that needs to be used. All of the, I don't know how many of you are chemistry people here, but all of the R groups have to be mentioned in each structure. There has to be a base main structure. All of that has to be drawn into a computer, put into a program, put it into the way the United States Patent Treaty Office likes it, and then I go through all of it to make sure that it is all good and it covers exactly what Dr. Little wants. Once that is done, I ask Dr. Little, okay, so when do you want to publish your paper? And he'd be like, I'm going to publish it next week on Wednesday. I'm like, perfect. So I'm going to get this patent published on Tuesday, so all of your compounds are protected. So nobody can come and say, oh, I saw his paper, I have the same compounds. I'm like, nope. I had them on Tuesday. I published them on Tuesday. Emory University has the rights to those compounds. Dr. Little is the main inventor on that technology. So that's the whole process of how I take the idea to a patent. Now, the patent's done. Great. Kudos, he gets to get his plaque on the wall saying he has a patent to these chemical structures. Woohoo. And then I say, great, now we have chemical compounds. So what's the point of just keeping them in the lab? So I have a marketing team in the office, and you'll see all of them on the slide. I have a marketing team in the office. I'll be like, hey Jess, I have this 15 compounds from Dr. Little. They need to be marketed. She's like, great, send me all the information. I send it to her. She has an intern who puts it all together in a nice, pretty way of talking science. And we send it out to all of the pharma companies around the country, around the globe. Out of that, maybe 5 pharma companies come to me. For example, say, Abbott comes to me. And we're like, hey Catherine, we really like Dr. Little's compounds. Let's talk business. I'm like, great, this is amazing. I'm gonna send you a term sheet. So I put together a term sheet. A term sheet includes how much money they need to pay me up front. For example, I might ask them to pay me $1 million up front. I want upfront fees that I get that will go directly to Dr. Little. Then I want royalties on those, compounds. So every time they use it, and whatever money they make off of the sales of those compounds, I will ask like a 7% royalty on that. Now, a term sheet would not just happen right away. It goes through many negotiations. Sometimes they give in, sometimes I give in. There's a whole process to it, after which then we enter into a license agreement. The license agreement is a 50-page document that includes all the legal terms, all the financial terms, all the parties included, and then I negotiate that license agreement. Once that is signed by all the parties, then we say Dr. Little's compounds are now licensed to Abbott, and whatever financial gain we get from that will be divided between Dr. Little, ODU, and his department. It gets divided 3 ways. And so that's when we say we've had a successful transfer of technology from the university to pharma. So that is technology transfer. And I just said that in 30 seconds. It probably takes 4 to 6 years for that to happen. So I could take a technology from the cradle to the grave. Grave is not bad. Grave is it's got licensed to someone else. That could take 4 to 6 years to happen. And so it's a long process, and a bunch of people are involved in that. So I am the licensing team. I am responsible to evaluate all the technologies that come into the university. We are a team of 9 licensing associates in the office. We have a bunch of I manage a portfolio of 350 technologies. So different types, physics, math, sometimes geography. I've had surgical tools, therapeutics, all kinds of technology. Sometimes it would be drapes for the surgical room. It could be as simple as that. Something that is sterile, something that can be moved by oral command. I've had that kind of technologies even come through my hands. So that 350 technologies is what I maintain, and I try to seek business partners to be able to license it out of the university. And then we have a patent group in the office. Their role is specifically to write the patent for me. I work with them to get a full patent drafted. We have a faculty and startup service. These are the people who go to people like Dr. Little and other professors on campus and say, hey, do you have anything new going on? Do you want to share anything with us? That's their role. And then we have finance and operations, and this is the back end of it. We don't really see them working, but without them, our office would probably be in ruin. So this is how our office is set up. And I kind of already discussed this with you, the whole process of taking the technology. But I missed this part, which is very important, is educate. It is amazing how many faculty members don't know that our office exists. They don't know that their ideas have value. They don't know that I could take their idea and I could set it up in a way that we could have other companies come and pay for them to do the work. We could also do what is known as a sponsored research agreement. This is where a company comes and says, I love what this faculty member is doing. I want to give him $300,000 and I want him to do this project. So I'm responsible to get that agreement in place as well. But education is very important. We spend a lot of time going to lab meetings or departmental meetings or even meetings like this where I talk about what we do because a lot of faculty members don't know what I do or how we can support them in their research endeavor. I've talked about the rest of it. I've talked about evaluating it, protecting the technology, marketing it, and then of course the whole licensing part of it. And the post-license, I don't really do much. I have a group that does that in our office. So you might think, oh, she has 350 technologies, so wow, she must be just bringing in the licenses every day. It doesn't happen. Over this last year, I've only had 3 licenses. And then even that, I had to like pull teeth to get done. They're very hard because out of all the technologies that come into our office, about 30% we decide not to pursue. Why we decide not to pursue? It's possible that a similar technology already exists, so there's no point going down that road. Sometimes the professor comes to us after they've already shared their idea with someone. No point, now I cannot protect your idea because you've already disclosed the idea. So another thing to remember as you go off to your graduate careers or you end up being a professor, if you have an idea, don't go blabbing about it. Keep it in your mind, write it in a notebook, and then find someone that can help you actually develop that idea into a patent and protect it. It's very important to keep these ideas in your brain or in a notebook that no one has access to. And then 80% of these technologies, no one knows what happened. It's either because the professor has left the university or he has decided he doesn't want to do that research anymore, so it just sits like that. There's nothing we can do about it. That's just the course of how technology transfer happens. And then the last very few technologies that actually go into full product development and actually go onto the market. So the challenge with technology transfer is what we call the valley of death, right in the middle. So you are a professor, you get money, you are doing your research, great, there's funding coming. You get a great discovery, you make a great discovery, we are here to support you with that discovery. But once the discovery is done, once you've protected it, now you need money to actually build it. Where are you going to get that money? And that's where the bazillions of technologies go to die at this valley of death because there's no funding at that stage. This is where usually universities will create a seed fund, or we have what is known as a proof of concept fund, where we give about $250,000 to inventors who need it to just push through that valley of death to actually create a viable prototype. Once you get to the proof of concept and you actually have a working prototype, now you can ask for venture capitalist funding or angel funding, that kind of area, and then eventually go into a full venture capitalist funding, seed A, seed B, seed C, and so on. So that's where most of the technologies go to die. So if you are able to, if you have an idea and you're developing it, this is where you will have the most struggle to get funding to actually develop it into a full concept. This is how we do it in our office. We've already talked about the first part of it. There are two ways. Once we decide the technology is viable, there are two ways it can go. It can go to an established company, like I gave the example. I license the technology to Abbott. Or the inventor can say, I don't want to license it to anyone. I want it for myself. I'm going to create a company called Little Co. And I'm going to keep all of the antibiotics with me. Like, great, okay, so let's do a license agreement. I meet with Dr. Little. He has to come up with a business plan. He has to show how he's going to create this company. He's going to show us where the funding is going to come. He's going to show us who the CEO is going to be, who his CFO is, the whole structure of it. We work with him and we negotiate a license and we send the antibiotics into him. Now, it's not that we just gave it to him so we just sit back and relax. He has what is known as diligence milestones. He has to come up every year and give me an annual report as to what he's doing with those antibiotics. If he's found in breach, if he's not developing those antibiotics, then we can terminate the license and get back those antibiotics back to us. So there's a lot of work that happens right after that licensing part, and that's where I come into all of these kind of different conversations with people. So what's the primary goal of technology transfer? And it may seem like very basic when I say, I want to better the world, but truly, that's our goal. We want to be able to take these ideas that these faculty members have been able to develop and push it into society to help society become better. That's of course the main goal, but we also want to make money through that. And that's through commercialization, like I talked about, the licensing, getting the money back into the university. For example, Emory will ask for a certain dollar amount for every license. That's because it's just not because we want the money, but a lot of money goes into the back-end management of these licenses. We have to find a law firm to work with us. We have to find a marketing firm to work with us. We need to pay those bills, and so we need an amount of money that comes into our office to be able to manage all of those things. And so like I said, it's an exciting thing when someone comes into the office and there's this great idea, but it takes 4 to 6 years minimum for an idea to get conceptualized into a product. And so it's not disheartening, but it's a process. It's like I tell people, if you're going to get into tech transfer, plan on being there for at least 5 years, because then you can see at least one product going from cradle to actually a full product into the market. I'm just going to play a small video here. I don't know if you know, but Emory was the one that the current HIV drugs that are on market. Any HIV patient, the drugs that they're taking today were developed at Emory. It's a 3-drug system that was developed by Dr. Dennis Leota. Not developed, he discovered it and then we patented it. This emtricitabine, and there are 2 more that he created that we patented, and that changed the face of HIV in this country, because at that point, people had to take multiple medications throughout the day. They had to take 1 drug per day and they were good to go, and their titer counts were low. So this is a short video of one of our greatest success stories. This was licensed to Pfizer. We're still getting like $1 million revenues of royalties from this technology. And so just going to play a short video on one of our success stories.
100 cases nationwide, 300 plus of those fatal. And every day, 3 more cases are identified. And yet, still, surprisingly few people are familiar with the Acquired Immune Deficiency Syndrome, or the acronym by which it's frequently identified, AIDS.
Federal health officials consider it an epidemic, yet you rarely hear a thing about it. At first, it seemed to strike only one segment of the population. Now, Barry Peterson tells us this is no longer the case.
The magnitude of the AIDS crisis really started to hit home. We saw some of our most creative people taken away from us by this terrible disease. And I just became increasingly convinced that I had to do something.
But unfortunately at the time, people didn't believe in combination for viruses. We had already combinations, of course, for TB and for cancer, but nobody believed you really need the combination for viral infections. And in fact, some people, famous scientists, came to me and they saw my work and said, great work, but you know, we'll never see the combination chemotherapy for antivirals.
On the very first shot, we saw something absolutely amazing.
The synergy between AZT in those patients and lamivudine or FTC was an enormous breakthrough. It led to the first combination drug, Convivir, and that was the first time, looking through CDC's reports and the weekly morbidity and mortality reports, where there was a downward deflection in the death line. It was absolutely correlatable.
Short of my wedding and the birth of my children, this was the most euphoric moment in my entire life, is when I saw the data presented that showed that the majority of people who were started on a 3-drug regimen, their viral load fell to undetectable, and their T-cell counts actually came up.
I was on Convivir, which was AZT and 3-2C, or AZT and lamivudine with Crixavan. And I showed a remarkable recovery. I became undetectable and had my T-cells above 200, and right now I'm they're in the 600 range, and I've been undetectable ever since. The therapy that came out at that time was literally a lifesaver.
I'm 35 years old and I've been living with HIV for all but 6 weeks of my life. My childhood, I was told that I was going to die. And then when I didn't, and I did graduate high school, it was kind of this unexpected adulthood. What do I do now? I guess I'll go to college.
So it was no longer a death sentence. HIV was no longer a death sentence. And that was amazing change because mortality dropped from 72% of people who have HIV to less than 25%. Very rapidly, thanks to hard therapy.
But this is the biggest success story that Emory has had, to be able to affect society in such a relevant way, to actually see those numbers of HIV people, the mortality decreasing, I still get goosebumps whenever I hear the story, whenever we have this play in any of our events, and I meet Dr. Painter or Dr. Shinazi or Dr. Leota, I am just like blown away because they actually took what was in their lab notebook and actually affected somebody else's life in this world. The next one, the biggest story, this is from 2022. This license agreement was signed on December 25th, 2022, so last year. This was a drug that was again developed by Dr. Shinazi and Leota in the people you met in the previous video. They had these drugs just sitting for years just sitting in their freezer. And then that's when the COVID-19 pandemic hit. And they decided to just test these drugs against COVID-19, and they were able to see a really remarkable effect. And that just put a huge push in getting that drug onto the market, and the FDA got involved, and then we signed the deal on December. I remember we were all on vacation, and all of our team's messages were going nuts because they were like, oh, almost ready to get signed, oh my goodness, Merck is gonna license this technology. And then like around 9 in the night on Christmas Day, we licensed the technology to Merck. And it was an amazing thing because we actually have this drug on the shelves in the US and Europe. And it actually it brings down COVID-19 levels. I think if you take it on day 2 or day 3, once you're tested positive. So they're exciting things to see. For me, this is really an exciting team to be part of because this is really affecting society in the realest sense of the word. So this is our team. I'm not going to go over each person. And the point here to say is, if you look at Todd Scherer, who's the head of the OTT office, and then the licensing team, we all have either a PhD or a JD. To work at the Office of the Technology Transfer, that's the minimum requirement, to either have a PhD or a JD. The people in the marketing, finance, and contracts team don't fall under that, but the rest of us, we have to have a PhD or a JD. So now I'm going to pivot a little bit from talking about technology transfer to my story of how I ended up with the PhD and my journey and my story with that. So this is kind of my doctoral journey. I'll go over here. So in 2006, I graduated with my bachelor's in pharmaceutical sciences from the University of Mumbai. If you can realize, I'm Indian. I was born in Bombay, India, one of the biggest cities in India. I did, after my high school, I went and did my bachelor's in pharmaceutical sciences. I had organic chemistry for 8 semesters and studying somebody. I took organic chemistry 8 semesters. The first semester I almost failed, and I realized, okay, I need a tutor. And so I got a tutor after college, and I loved it. I fell in love with organic chemistry. No matter.
Say it again one more time, please.
I fell in love with organic chemistry. This tutor was amazing, but the one piece of advice she gave me was you have to go home, you have to spend an hour of what is taught in class the very same day. You have to go home and write down what your professor has taught you the very same day. And now I'm not talking, and I was talking to my niece and nephew, they get done at school at 3:30. I used to leave home at 6:45 in the morning to go to school. And I used to not come back home till 8 in the evening because I had 2-hour commutes one way to go to school and come back. After that, I would sit an hour and work on organic chemistry for an hour. I didn't do anything else. I did organic chemistry though, because I knew if I didn't do it, I'd fail. I knew I'd fail. And I aced it. I fell in love with organic chemistry, and we were forced to take it because we had organic chemistry on one side and we had pharmacology on the other. So if you didn't do organic chemistry, you couldn't do well in pharmacology. So there were two combined together, and so we were kind of, so one piece of advice, do organic chemistry every day. It'll be good for you. Anyway, so I graduated with my bachelor's in pharmaceutical sciences in 2006. I got a job right away after I graduated. I was working for an editing company. I would edit papers, scientific papers for scientific accuracy as well as English grammatical errors and so on and so forth. And so I did that. I wasn't sure what the future would. I didn't know what I wanted to do. I wanted to make money, which is, everybody wants to do that. I wanted to make money. And so while I was doing that, I was recruited by GlaxoSmithKline to work for their clinical trials office in Mumbai. It was great. The office was 10 minutes from my house. It was, I was making way more than I thought I would at that point of my life. I was like, great, this is great. I'm just going to stay here. I'm going to climb the ranks, and wonderful. My dad would let me go. He was like, you need to do something bigger than this than just sitting in an office each day. Let's, get some more education. And I was like, I don't want to study. I'm done. Studying is studying is good. Everyone's studying. But I was like, I don't want to do this. And so at that point, serendipity, destiny, whatever you want to call it, God brought somebody into my life. He was a super senior guy. I'm sorry, my office DMs are going off. Somebody met me who was a super senior, who was like 4 years my senior in college. He's like, hey, did you ever consider going to the US and getting a master? And I was like, nah, who's gonna do that? Why would I leave the comfort of mom and dad's house and go to the US? He's like, just try. I was like, so I talked to my dad, and my dad was like, okay, I'm willing to fund it if you want to go. And I ended up being here. I got through. I went to Creighton University, go Blue Jays. I did my master's in pharmaceutical sciences over there from 2007 to 2009. I took a year gap in between to do all the applications and all of that. I decided to do my master's in organic chemistry. That didn't go well. I took organic chemistry my first semester of my master's, and I was like, no, I'm done. No, it's not gonna happen. So I fell back to my other love, which was biology. I always loved biology from when I was little. I love the human body, love everything about the human system. And so I decided to rotate through a lab that was doing developmental biology. And this professor was creating transgenic animals, where we would use genetic manipulation to change genes that were responsible for proper limb growth. And so I studied the effect of genetic manipulations on the feet of these mice. And so I created these animals that would have like more than 10 digits on one hand. And I would manipulate their genetics to do that. So I absolutely loved it. I played with mice for 2 years. It was amazing, great experience. I thought, this is science. I want to be in it, and I want to, become a professor, and I want to change the world, and this is for me. And I was all pumped up about it, and I had a great mentor. My master's mentor is one of the best that I've ever had. She taught me life skills. She taught me lab skills. She corrected me. She mentored me. Amazing. Had a great journey. That is Grace and Matthew for my graduation. In 2009, I graduated with my master's. I had to shave them a little bit. That's just what I'm saying. And then in 2010, so then I decided, okay, I'm done with education now. No more, man. I'm not doing anything. Well, the market crashed. I applied. I don't know how many jobs I applied and how many rejections I got. They were like, we just can't take entry-level people right now. We just don't have the money to do it. Can't do it. And guess what? I'm also an immigrant. I can't stay in the country legally for more than 90 days if I don't have a job or if I don't have education. So I was like, I don't know what to do. I was freaking out. I presented my thesis at a poster session, and this person happened to walk by, again, I think serendipity, God. This person walked past my poster and he was like, you create transgenic animals? I was like, yes, I do. And he's like, great, I make transgenic tumors. I was like, great. He's like, would you consider doing a PhD in my lab? I'm like, no. He was like, why? I was like, I don't want to do a PhD. He's like, it'll be great. This is great. This is exactly what I'm doing. I'm like, Dr. Wagner, I do not want to do a PhD. He's like, consider it. Just consider it, in this German accent. Consider it. Just consider it. Okay. So I can call my dad, and Dad's like, do it. What's the harm? 5 years, it'll be done. So I applied. I didn't want to, so then at that point I decided I want to leave Nebraska because I was like, why are you in Nebraska? What's in Omaha? Well, anyway, I decided I'm done with Omaha, I want to leave. But life and circumstances kind of forced me to be there. I applied to the University of Nebraska Medical Center for their cancer research program to do my PhD. Got through, the interviews were great. I didn't end up going to Dr. Wagner's lab for a variety of reasons. And I decided to go to another lab to do my PhD in epigenetics. And so epigenetics are minute changes that happen to your genetics that change the way your DNA behaves. But I did it specifically in pancreatic and colon cancer. I also checked we had a bunch of new drugs that we had developed in a lab that worked next to us, so I worked with them to test those drugs on epigenetics. So that was my overall thesis project. Loved the science, absolutely enjoyed going to the lab. I worked with, mice and developed pancreatic tumor models to test, because pancreatic cancer is one of those deadly cancers where by the time you find out you have pancreatic cancer, you're half dead anyway, and you're going to die in 6 months after that. So it was a very passionate thing for me to work on, late nights, early mornings, cell culture, did the whole shindig, absolutely loved it. But turns out, and this is where my story kind of starts to take a little bit of a dark turn, the PI, or the boss I reported to, was a great person. Absolutely loved him. The reason I joined the lab was because of him. But he was one of those very famous people who would be in Washington, D.C. all the time doing study reports or whatever, grant reviews. He would never be in the office. Under him, there was a lady that I would report to on a daily basis. What happened was I ended up having a very toxic relationship with her. I would say I was verbally abused multiple times, close to being physically abused a few times. A lot of negative things happened to me in that time. And as an immigrant, I don't know if most of you would feel that, but as an immigrant, you can't just make quick changes. I can't just go up and say, you know what, I'm done. I'm not coming to lab anymore. I'm just going to stay home. I can't do that. My visa status is that we'll be in trouble. I can't just go into my advisor and say, you know what, I'm done with you, I'm going to find another lab, which means I would lose another 2 years of my life to restart the PhD program. And so I decided and made a very, I would say, looking back was not the right decision, but I decided to stay in the lab. And it was not good for me, for my health, for my mental health. It was not good. It was a very bad situation that I was in. And this was in the 3rd year of my PhD that I decided I'm done with science. I can't do this research anymore. I can't come in, deal with people like this day in and day out, being yelled at, screamed at. I can't do this anymore. Right around that time, again, God or serendipity, we had a major cell culture contamination. I don't know if you understand that, but our cells weren't growing, there was bacteria everywhere. It was a very bad situation. We had to close down our floor. We had people come in to clean our floor and clean our, I don't know, the ceilings, the walls, and cleaning everything. And so we were forced to sit in our office and work on our laptops, either read papers or, I don't know. I just read papers at that time. But at that time I decided, all right, I need to decide what I want to do with my life. If I'm not going to continue research, what do I want to do? And that's when I actively, those 10 days that we didn't have, I couldn't do active research, I spent and I researched, I created an Excel sheet, I wrote down all the possible positions that I could do after a PhD, because I'm not going to quit my PhD, I'm going to get it, I want the PhD. I created a full list of it. I started finding people who I can associate it on LinkedIn with these positions. I made this entire Excel sheet and I started reaching out to people on LinkedIn. I would say the last year of my PhD was the worst. I was pushed to a corner. There were a lot of negative things that happened. I finally had to reach out to somebody higher up than my boss and tell them that this is what's going on. They couldn't do much at that point. They were like, just suck it up, you know, last year of your PhD, just get that thesis, get out. So it so happened that my papers, the paperwork that is due for graduation was to be submitted at 4 o'clock on Friday. The lady that I was reporting to was supposed to sign off on it, and she didn't sign off on it until 3:50. I was literally on my knees in the graduate room, crying because I didn't know what else to do. There was nothing else to do. If I didn't graduate then, I had to spend another semester in my PhD. And I knew I couldn't do that for my mental health. And so I begged her, I pled, and I was like, please, just one signature, let me go. And so she finally did at 3:50. I took my car, I illegally parked in front of Graduate Studies. I ran into the office, 3:59, I submitted my papers for graduation. It was the worst experience of my life. I finally take a deep breath, I come out, and then I call my husband and I'm like, hey, I'm done, it's done, PhD is done, it's over. He's like, all right, get to the PICU at the Children's Hospital because our daughter is in the ICU. What? What are you talking about? Turns out she had RSV, you know, she couldn't breathe, they had to get an ambulance, drive her to the hospital. It was just the worst day of my life. And so the PhD for me, even when I'm talking about it, my stomach hurts because it just has so many negative connotations associated with it. Do I love the science? Absolutely do. Do I love all the friends that I made in graduate school? They stood next to me in my wedding. Amazing friendships. But the mental struggle that I had is real, and it was very hard. So I'm gonna step out of that, and I'm just gonna talk to you about how I made my transition to technology transfer. So in my 3rd year, I'm good though. I'm good now. Everything's so somber. I'm okay. Though I was stirring up because whenever I tell the story, it affects me physically. So in the 3rd year, I decided that I need to find out what I want to do after my PhD. I have 10 minutes. I know I'm good at teaching. I like teaching. I've taught classes in the past. I'm not nervous when I stand in front of a crowd. So I was like, all right, teaching is an option. I looked into medical science liaison. I don't know if you've heard about that position, but it is where they require PhD people to go talk to doctors about a new product that's coming to the market and educate them about it. I was like, this is great, you know. So it was MLS on top. Then there was teaching, and then during my 4th year of my PhD, our tech transfer office had this seminar series on intellectual property. It was at 4:30 on a Friday, and they were giving out donuts and coffee. I was like, perfect. So the five girlfriends, we all went every Friday we would get donuts and coffee, we'd sit in the last seat way in the back, and we'd be like, you know what, we're getting a certificate out of it, I'm just gonna go sit. Absolutely loved it. I love the fact about the whole concept of intellectual property, the whole concept of protecting an idea blew my mind. I was like, this is great, this is amazing. And so I reached out to my tech transfer office. I was like, do you have any internships that I can do? Can you please help me get an internship? And they were like, yeah, we'll open up in a few months, reach out to us when you're getting close to graduation. Well, I was getting close to graduation, I reached out again, there was nothing available. Now I'm freaking out. And so I was like, is there anything else I can do? Can I do free work for you? Can I just come sit in your office? I just want to learn what you're doing. And they're like, well, we're planning to do a boot camp. Would you be interested? Absolutely. So I did the boot camp. I learned all that I could about the technology transfer. This was about 4 or 5 months before I graduated with my PhD. I took it on myself to interview about, I would say, 50 to 60 tech transfer offices all over the country. I would email the program manager, I'd be like, hey, can I talk to you? I just want to know what you do. What is the job? What does it look like? How much do you make? Is this even a viable role for me? I talked to 50 to 60 people. They all gave me information. I had an Excel sheet that I put all of that information in. And slowly but surely, tech transfer kind of took the first spot over MLS. Now I'm graduating. I applied to the Moffitt Cancer Center in Tampa. Interview went great, offered me a position, supposed to start January 4th. I'm graduating December 19th. This is amazing. Finally, life seems to be turning around from this mayhem. And then I find out I can't move to Florida because of immigration. My husband's immigration is filed in the state of Nebraska. They won't let us transfer to the state of Florida. This is 4 days before I walk across the stage. And I'm like, this is awful. I call up Moffitt, I'm like, sorry, because of immigration I can't move. I was the only person in my graduation line that didn't have a job lined up. 4 people on this side, 4 people on that side. They're all like, oh, I'm going to Stanford, I'm going to do a postdoc, I'm going to Duke, I'm going to UNC. And they're like, Catherine, what are you going to do? I'll figure it out. And the worst part is, again, I have the 90-day deadline to find a job, otherwise I'll be illegal in the country. So I come out of graduation, and I say this in shame, but I did not take any pictures of my graduation. The pictures that you see over here, I borrowed them from my friend's Facebook page when I created this, because I had so much shame associated with my PhD, because I felt like I didn't do a good enough job. I could have done a good enough job if I had a good mentor. I had so much shame associated with it, I just could not handle it. And then standing in the graduation line without a job lined up really shook me as a human being, because my worth was in my PhD. That wasn't right, but that's where I was. And so all of these people had jobs lined up, and I'm here standing with a PhD with no job, and that really shook me. Well, you know what they say, you pull up and you do what's needed to be done, so I looked for teaching jobs. I taught biology 101 at a local community college to a nursing student, nursing class from 8 o'clock to midnight, 2 days a week. I also taught at a local school. I taught biology, physics, and chemistry to the high school students. And then I also took up a job because I have to maintain 40 hours of work to stay legal in the country. So 20 hours at the community college, 10 hours at the high school, and then I worked as a freelance scientific writer for a company for 10 hours. That made my 40 hours for me to stay legal in the country. I did that for 3 months. I reached out to everybody I knew. Everybody and anybody, whoever's uncle, grandfather, grandmother, didn't matter. I reached out to whoever I knew and I said, hey, is there anything that you can give me in the state of Nebraska that I can work? Would you please help me? Nothing seemed to be working out. I was really at my wit's end, to the point where after I graduated, I ended up having a panic attack that I did not know was a panic attack. Thought I was having a heart attack, was rushed to the urgent care. My sister took me to the urgent care. Turns out it was just severe panic and stress from my PhD. But I kind of learned to deal with it. Eventually, I reached out to the tech transfer office, which is UNIMED. UNIMED is the tech transfer office for the University of Nebraska. And I was like, hey, is there anything you can help me with, please? I need something before this particular date, otherwise I'll become illegal in the country. And I had 2 friends who were working at that office, and they really put in a good word for me, and they were able to open up an intern position for me. and that's how I got into Unimed, and I worked there for 5 years in the tech transfer office. After that, after which I was then able to be moved to Atlanta 2 years ago, and now I work at Emory in a similar office. But that's my PhD to tech transfer transition story. I don't say this to scare you or to be like, oh my goodness, the PhD is the worst experience in the world. I'm not trying to say that. We all have different experiences. I have friends who've had amazing PhD stories. They've published, they've grown, they've learned. There are a lot of people, I'm sure other people who have done PhDs over here have had great experiences. My experience was bad. But it comes down to a few things that will change the way you pursue your career after you graduate from your undergrad, or whatever you do in life. Micro decisions, networking, and preparations. Micro decisions. In my 3rd year of my PhD, I decided I didn't want to do research anymore. That was a major decision. But to get to that point and to move forward, I had to make a lot of small micro decisions. I started attending seminars like this, tons of seminars like this. If it wasn't at my university, I would drive to another town to attend another seminar. I would get that person's email address. I would look them up on LinkedIn. I would email them. I would say, hey, I really liked your talk today. Can you tell me more? Can you tell me what I should do to be like you? What are the skills that I should learn? I would not hound, but I would like ask questions constantly to these people who would come to give seminars. Most people want to help. You may think, oh my goodness, I'm bothering them. Most people want to help. And especially for me, my passion is to help undergrads. I've helped a ton of people. Even today, I got an email from an undergrad in Emory saying, I don't know what to do, can I please talk to you for 30 minutes? Happy to do it. Can't do it this week, but let's meet next week for coffee. Most people want to help. You have to ask. Networking. Get your LinkedIn profile set up today. Go and create your LinkedIn. You'll be like, what have I done in life? I have nothing to show. I'm just a freaking undergrad. Doesn't matter. Do it. Talk about your clubs. Write about that. Put that on there. Talk about other extracurricular, co-curricular activities that you're part of. Put that on your LinkedIn. Put a picture on your LinkedIn profile. Don't leave it empty. Get that started today. Set it up today. Micro decisions will change your life in the future. Preparation. You don't know what you want to do maybe 2 years from now. Get an idea. If you don't know, go talk to people. I talk to like 30, 40 different types of careers. I talk to sales people. I talk to marketing people. I talk to pharma people. I talk to scientists in pharma. You have to take the initiative, go talk to them, reach out to them, find them. If you don't know where to start, go talk to your faculty members. They're happy to help you, I'm sure they are. If Dr. Little has invited me, he sure thinks he wants to help you in your career path. But if you don't ask, no one's gonna help you. You have to ask. You have to take the initiative to develop that. Look for internships. Internships are truly important in setting yourself up to success. I don't know what the internships in the Ohio area are. I can't speak to that. But you have companies here. You have even pharma companies here. If you want to go down that route, look up those places and get those internships in place. Sometimes they may not even be an internship program. But since you reached out to that person and said, hey, I'm interested, can I just follow you for like 30 days and see what you do? Do it. Some people will say yes, and you'll get this experience, which is life-changing. Ask, like I said, ask questions. If you want to ask me, I have my visiting card right there, and I have a little sticker that you can take away from today. Ask me, reach out to me. I'm on LinkedIn, I'm on Twitter, I'm on my own email address. Ask me questions. Happy to help in whichever way possible. It may not be right away, but I will reach out to you and I will talk to you. That is my passion. Because of how much I struggled in my PhD, I vowed to help anyone who asks for help in whichever way in your career. If you want me to look at your resume, you want me to look at your cover letter, I have looked at least 3 personal statements this month alone from undergrads because they're applying and they want me to look at it. Happy to look at it, happy to give you my edits. What you do with it, that's up to you. I'll give you my best that I can. If you don't ask, no one will help you. Mindset, change your mindset. Change your mindset to where you want to be 2 years from today. I am at a senior licensing associate position today, but my mindset is where I want to be, say for example, a director of a tech transfer office. My mindset is there. I want to be there. I'm going to change my thinking to be there. I want to be in medical school. What do I need for that medical school? I'm going to start those habits today. What can I do so I'm successful 2 years from today? But I'm going to start that today. Does that mean I wake up at 5 a.m. every day? I'm going to start that today. Do it today. Change your mindset to where you want to be 2 years from today. That is where success lies. It's where you change your habits. It's where you change your mindset. It's where you set your mindset to success. If you're going to say, man, I'm just going to do the lab, and then I'm just going to do my homework, and then, I'm just going to play on the, whatever you play, I don't know what you play. I'm just going to play. That's great, do it. But then block it up. Say I'm going to play for 1 hour, and then after that I'm going to work out for 30 minutes, and then I'm going to look up on LinkedIn 5 people that can influence my career. I'm going to look up 5 people today. I'm going to follow them. I'm going to comment on their statuses, and I'm going to send them a message and say, hey, I like what you do. You inspire me. I'm going to be following you. That's all, a 3-word message. I like what you do. I like the work that you're in, and I'm going to follow you. That's it. Those messages, 5 years from today when you're looking for a job and you reach out to them, they will see that old message that you sent, and they're like, you know what, this person was interested from the beginning. Maybe I should give them a shot. But start today. Get your LinkedIn, get your social media, whatever you need to do, set it up. Set yourself up for success, but the success starts here in your brain. You need to change your mindset to a mindset of success. Last, I just want to talk about it. I know I'm going a little over. To those who want to go to a PhD program or going to graduate school, just a few tips and advice. Research the school. Not all schools are created equal. If you like a smaller school, go to a smaller school. You want to go to Howard, go to Howard. I was advised against going to Howard just because it's too big. Research the programs. Sometimes the website will say something, but what they actually tell you will be different. You need to go talk to the program advisor and say, hey, tell me exactly what the course study is. Tell me exactly what the expectations from me are. Reach out to the ODU faculty here. If you're not sure about the program, hey, Dr. Little, can you look at this website? Does this make sense? Am I reading this correctly? Am I interpreting it correctly? Ask him. Ask people like him. They're willing to help you. Go to their office hours and ask them these questions. Biggest advice, if you're going to a PhD program, talk to the lab people. They are the ones who are going through the ins and outs and the struggles of every day. Talk to them, ask them, hey, do you go out on the weekends? Do you work on the weekends? Do you have a family? Does PI encourage you to have a family? Ask those questions, very important, make or break. Have an exit plan from day one. Whichever program you go to, what are you going to do after that when you exit that program? What is it that you want to achieve at the end of it? Don't think of that on your 4th year of your program. That needs to be in your mind the first day of your program. What am I going to do at the end of this program? Where am I going to land? And how am I going to land there? And who should I be reaching to be able to land there? And always have backups. I had 3. I had medical science liaison, I had technology transfer, I had teaching. I had 3 things in my mind I knew that I wanted to do after my PhD. Have backups, very important. Failure is real, it'll happen. You're going to fail. Accept it today, best way to go forward. Accept that you're going to fail. Learn to pivot. Learn to pivot. Whichever failure you get taught about, a few degrees, you will find success. Just turn, figure it out, ask questions. Again, mindset of success is very important. Have a support group. Extremely important. I had 3 girlfriends in grad school. We cried together, we ate together, we studied together, we walked with each other some really rough times. You need a support group. Find a support group that will correct you. Very important. You need people who tell you, you are wrong, you are being stupid. So find someone who will correct you. Extremely important. If you find buddies, that's pointless. I mean, no, I'm not saying that. Find buddies. You need buddies who will walk with you. But find that one person who has the ability to correct you. Those are the people who will tell you when you're going wrong, and you need that. Last of all, very important, the mistake that I made, your worth is not defined by your educational success. You are so much more than your degree. You are so much more than what you achieved through your education. Remember that when you fail, that you are not defined by your education. You're so much more as a human being. Your education is just one part of your life. Yes, you want to be successful, but it's still one part of your life. That's it.